All right, I actually did not know what I'm going to talk about today until about 2 days ago. And when I mean talk about today, we're just going to mention this before we get into the lecture proper. We're going to be talking about classes, moving on to the next chapter. I wanted to show y'all something pretty neat that I think I will start encouraging people to do. May introduce it early in future chapters, which is other ways of printing. What if you had this? X is equal to 20. And you did print, parentheses, F quote. My favorite number is curly brace, X, end curly brace, end quote, in parentheses. And that's pretty wild. Print, parentheses, F quote. The answer is X plus 2. That's just kind of weird. So it's doing lexicographical substitution here to where whatever this is gets filled in with the value of whatever expression or variables that you need to put there. So if you have name equals, how about FN equals Bob, and you do last name is equal to Roberts, and you could do print, my name is first name, last name. So it's just another tactic that we have for printing, but I think it's kind of neat. So it was introduced with Python 3.6. So this functionality has been out there for about 2 years, I think. And you can do more formatting, than what we've just done here with some of these modifications we've seen in the past. Like if we have a number here and it's a floating point number, V is equal to 3.1415. You do print F, not print F, that's C language there. The result is V, but what is V? It's really a floating point number, and we want to show only 2 decimal points for it. So after the colon, we're giving some format specification. We're saying it's a floating point number and to display 2 digits of accuracy after the decimal point. So sure, you could always do the other things. You could always use dot format, or you could use a %sign or whatever, but I'm thinking I like that. I'm thinking about switching over to that as my primary way of formatting printed output. I'm not sure there's a drawback, except unless you're programming for systems that don't have Python 3.6, but Python 3.6 has been out for quite a while. We're well past it. So anyways, onward and upward. Classes. What is a class? Well, this slide just jumps right into the middle of it without even talking about what a class is. What is a class? It's a blueprint for a collection of data and then the methods or functions that use that data. So class is a blueprint for a collection of data and the functions which in class object-oriented programming are now going to be renamed methods. I may still continue to call them functions, but more correctly, they're called methods once they are attached to data. A function is a method. So class definition is like a blueprint. Well, it is a blueprint for each of the objects of that class. It contains the definition of all the methods and a definition of all the data that is used to maintain the state of the object. Well, what's like the state of the object? Well, imagine you're drawing Pac-Man on the screen and you need to know whether he's going north, south, east, or west. So that might be a piece of data stored in him as his current direction, right? And whether his mouth is open or closed, right? That kind of stuff. That's all of his data. That's his state information. And then all the methods that the object recognize, that the object supports. So for example, we could come up with a class that represents a fraction. It's going to have a numerator and a denominator. I may just call it top and bottom because I'm childish. So we're going to have a class and we're going to call it fraction. Come back. We need to define a couple of things for this. It's pretty much mandatory for us to add an init function. And when I say init, I mean 2 double scores, the word init, and then 2 more double scores. This is called the constructor. It is called when the object is created. If you've taken any other object programming courses, you've seen reference to the this keyword, THIS. Python's inventor, I have no idea why, but he chose the word self instead. And so I'm going to write this in 2 different ways, and then I'm going to change it to the way that the Python books show it. But the Java programmers and the C++ programmers will recognize something like this. If you see define underscore underscore THIS underscore underscore parentheses, this comma top comma bottom, and we're going to set our variables. We're going to set the data that this object owns. So this dot top is equal to the top, the numerator. This dot bottom equals the bottom, the denominator. And that's the end of my class. So I'm going to create a fraction now. F1 is equal to fraction of 1 over 2, right? F2 is equal to the fraction of 3 over 4. Now, I don't know why I put the word this here. That's a grievous mistake. I just said I was going to add an init keyword there. So that's what that is. Now I'm going to refrain from calling it this, although I would really like to do that just to be consistent with every other programming language. I will change that to the word self in just a minute, but what this is doing is when the fraction is created, we're going to pass in these 2 pieces of data that fill in these parameter variables, and they set the values of this object. This object's data is initialized with these values that are passed in by the init method. So, since Python's way of life is to do it that way, then I'm going to change it to that. And remember, variable names are meaningless. You know, I could call this whatever, you know, I wanted to do. You know, I could call this, you know, Borky, as long as I used Borky everywhere, you know, in the same consistency. That would work just as well. Stupid. Let's get it back to that. All right, so what can you do with a fraction? We might want an evaluate method that'll return a value of it, right? So 1 over 2 is equal to 0.5. 3 over 4 is equal to 0.75. Init missing 1 required positional argument. Bottom. Oh, you know what? Been using idle for years and years and years, and I think maybe I knew this at one time and I completely forgot it. If you want to know the line number of things, sure is easy to find them. Window, options, show line numbers. How about that? Ooh. Okay. So here was my mistake. Why did I think that I was going to do that, and I'm really sorry that I made that mistake. Here we go. So we're passing in 1 and 2 as our arguments to fill in the top and the bottom. And we're passing 3 and 4 in to fill in our top and our bottom. So let's make a method called eval. Eval. And we're going to evaluate ourselves. And so we're just going to return ourselves top divided by ourselves bottom. So F1 equals end quote comma F1. Why not use that newfangled style formatted print? F2 equals, now I made a mistake in that last one. I need to correct it. It's not just F1, it's F1 dot eval, right? So that's going to call our eval function, our eval method, which will divide the top and the bottom, return it so that we can print it out. And so F2 equals curly brace F2 dot eval in curly brace, or open parentheses, close parentheses, in curly brace, end quote, in parentheses. I don't know. Still just toying with that one, with this syntax. The F meaning formatted print, right? And it does a lexicographical substitution, evaluation of whatever's in the curly braces. Let's give it a shot. All right, so 1 over 2 is equal to 0.5, and 3 over 4 is equal to 7.5. I think I'm going to kind of punt on that for a little while, get back to doing it like that. Just that if somebody looks at these notes before they look at the lecture, it won't look too weird. Okay. So what if we just wanted to be able to print the object itself? Right now, we try to print that out, what we're going to see is the class name and then some kind of hashed memory address there. And that's kind of par for the course, but you know, it'd be nice if we could actually print out. And when I mean par for the course is what happens, I'm going to delete these 2 lines. This is just for demonstration, but if I import the turtle class, and then I create a turtle, type today, there we go. And then I print that turtle out. My brain's broken. I'm not going to try to figure out what I'm doing wrong here. What I need to add to this function is a function that will convert it to a string, a method will convert it to a string so that I'll see something a little bit more interesting than just the name of the class when I try to print it out. So I'm going to, that was weird. So I'm going to define a function called underscore underscore str underscore underscore parentheses self in parentheses colon for giggles. What we're going to see at first is it's going to print out just 2 times in a row. Look, Mom, a fraction, right? So when we call print like that, it should return a string version of itself. This function is returned. Why? Because print is expecting a string there. And so the Python runtime engine says, oh, you want a string? Well, I better make a string out of you. And it tries to call the objects underscore underscore str and underscore, right, in order to call it. Let's give that a shot and see if it actually prints, look, Mom, a fraction. It does. So we have our fraction defined called F1. We should be able to get a list of all the methods that a fraction class supports. There we go, right? These are all of the functions that are attached to that class as of now, including init, including eval. There should be one called eval, and including str. There sure are a lot of things we didn't add. Well, that is true. Every class you create has all of these methods except for the eval built in. They are inherited from the root object class. And we don't normally care too much about them, but I'm curious about this size of one. Is it possible to print out the size of the fraction? What would happen if I did print f1 dot underscore underscore size of underscore underscore parentheses in parentheses in parentheses? All right, the size of it's 32. It's occupying 32 bytes in memory. I saw a brief pop-up helper text here. I'm curious. Print, I want to see that again. F1 dot underscore underscore size of underscore underscore. The size of the object in memory in bytes. LT stands for less than. GT stands for greater than. LE stands for less than or equal to. GE stands for greater than or equal to. EQ stands for equal. Well, how would you know that two objects are equal or not? Well, if their top and their bottom are the same, or if you call eval on it, right, and the results of them are the same. So when you're testing equality of something, if we create two separate objects right now, right, F1 is one object, F2 is another object. We should actually go back and finish this code right here. But I want to show you something first, finish this thought. If F1 equals F2, print F1 equals F2, else print F1 does not equal F2. And they do not equal F2. Why? Because if I call equal and there's nothing else added to the class to make it behave any differently, all it's doing is checking the memory addresses. Are F1 and F2 occupying the same memory address? No. The only way that they would occupy the same memory address is if we've done something like this. F1 equals F2. Now that does not create a brand new fraction. We now just have two references to the same object in memory. This actually allocates the bytes for the object. This is a reference to that, just like an address, you know, and this is just copying the address of that object into another variable. Vice versa, it should be F2 is equal to F1. That would be a syntax error. Sorry about that. So F2 is just a copy of the address of that one. Now we have two references to the same object, just like I have two names, right? You know, I have a full name, Jeffrey Glenn Thompson, but you could also call me Professor Thompson. It's the same thing, right? I have two different names, the same thing. You could have, you know, two street signs pointing to the same street. It doesn't matter which sign we go through, we're still going to get to the same street. So F1 is not a copy of F2. F1 and F2 are actually pointing to the same memory. Now it is going to say that they equal. and they equal. But how often do you have two references to the same object, right? Not normally. So I'm going to take it back to the way it was. And so for now, it's going to say that they're not equal. If we want to be able to compare objects, we need to add an underscore EQ function to this. And so what are we doing here? We are testing this object's self against other. We're going to see if our self is equal to our other. And when I keep saying we have pieces of data here, I think that I should have mentioned a little bit more about what our top and bottom are. I never actually did anything to them, right? Print F1 top equals end quote comma F1 dot top. And then X is equal to F1 dot bottom, right? Y is equal to F2 dot top plus F2 dot bottom. I'm just doing stupid math here to show. These are the pieces of data that is stored in it, right? We have a number. Each fraction has a top and a bottom, a numerator and a denominator. So let's go ahead and make the string function return something useful rather than that. How about returning the words fraction top equals placeholder 0, bottom equals placeholder 1, end quote, dot format, self dot top, comma, self dot bottom. I can't help it. I really want it. I'm so tempted to use that new form of printing. But I'll stick with it. Okay, so there. Fraction top equals plus placeholder 0, bottom equals placeholder 1, end quote, dot format, this dot top, comma, this dot bottom. So now when we print ourselves, it's not just going to say, look, mom, a fraction. It's actually going to print the object name and its data. Or not, because I called it this, and it's called self, excuse me. Self dot top, self dot bottom. And I have an error in the formatting string. Oh, why do I have two closing curly braces? Because I meant to put a parentheses there to match that one. All right, so the fraction is 1 over 2. Apparently, I did not print both fractions. I thought I had. No, I only printed F1. Print F2. All right. So we're going to finish the EQ function, or we're going to write an EQ function so that we can compare them and check to see if their values are the same. And how are we going to compare them? We're just going to call the eval function on each one of them, and if they are the same, then we know that the object values are the same. So DEF underscore underscore EQ underscore underscore self comma other. We're going to be testing ourselves against the other thing that is passed in. So if self.eval equals others.eval, then return true. Otherwise, return false. Right, and they are the same. I guess at a certain point, I thought I had them as different fractions. Oh, I did. What happened there? All right, so 3 comma 4. One fraction is 1/2, the other one is 3/4. They are not the same, but they were the same when they were 1/2 each. Or even if it was like, 2/4, right? Because 2/4 is equivalent to 1/2, so they're going to evaluate as being equal. Now, when I did dir of the fraction class and to list all of the functions, all of the methods attached, there's not only EQ, but there's less than, LE, there's greater than, GE, there's less than or equal to, greater than or equal to, there's not equal to, right? And if we wanted to, we could do all of that, right? We could make it so that we could compare two objects. How would we know if one was less than the other? We could just call eval and see whether, that eval was less than the other. I'm not sure exactly how far to take it, but I think I'm going to go ahead and implement not equal as well, which is just going to be the exact opposite of equal, right? In fact, I could even call that EQ function. So define not equal, self comma other, and return the not version of EQ's other. Maybe we could get rid of that. This may bug you. It kind of bugs me. But notice that, you know what, I'm just going to wind up deleting this one. Am I not equal? Put a print statement on this one. Print. Am I equal? So when we check to see whether they are the same, right here, it's going to print, am I equal? Right? And then it's going to return its value. I haven't used not equal yet, but I could check, right? So down here, if F1 not equal to F2, print, nope, F1 not equal to F2. Right now they are equal, so we're not going to see that message get printed out. I'm going to bail out on getting that to work. One thing I wonder is if I just delete this, is it smart enough to know that it could use the EQ function and return the opposite, the not value all by itself? Yes, yeah. So in order to check to see if it's not equal, it's just going to call the equal function and return, the opposite in order to do that. So that's enough. And how would you check to see if something was less than the other? You would call their eval functions. I don't feel like doing that. I don't feel like fluffing this up any more than we already have got. It'd be nice to do that. It'd be nice to implement a less than function and a greater than function and less than equal to and a greater than or equal to. But I think this is about as far as I want to take that. Okay, now there's a whole bunch of other cool stuff we could do with fractions, right? Why would you be storing this data? Well, you might want to be able to add the two values to get together, right? You might want to, multiply fractions, divide fractions, subtract fractions, whatever. We're not, the only useful thing that we've done to it so far is this, which would, return the fraction in a numeric form. This EQ method is not written with the same level of robustness as the one that's shown in the book. And what do I mean by that? What if we did something like this? If F1 equals 3 colon print yes 3. These are not even of the same type, right? We have a fraction that we are comparing to an integer. Or what if we check F1 against Bugs Bunny, right? It's absurd, right? Well, unfortunately, it's so absurd, it's going to crash. Why? Because the string function does not have something called eval. So they are not compatible classes. So we should not be comparing them. This example of the EQ function is more robust because the first thing it does is just to check to see if we are comparing against ourselves first. What does compare against ourselves mean? It's just doing this. If F1 is equal to F2, right? We're comparing we're comparing two objects there. But if I did this one, if F1 is equal to F1, it's axiomatic that those are true, right? F1 has to equal itself. So that's the first thing that they handle, is just to check the memory addresses to see if they are the same. So if the self equals the other, it's the same object. So we return true. Now that doesn't fix the error that's going to crash here, but it's a good thing to do, right? Because if our memory address, if we're checking to see if F1 is equal to F1, that's all we need to know, right? Is that they occupy the same memory. That's enough. If this class has 75 pieces of data and we need to compare all 75 of them to determine whether the objects are equal or not, if we're checking to see if our self is equal to our self, we don't want to check all 75 pieces of data. So that just kind of rules that out. But to handle the case of where we are passing in different data types, if we're comparing ourselves to a string or we are comparing ourselves to an int, we check our type. If the type of our self is not equal to the type of the other, then the objects are not even of the same type. And so, of course, we cannot be equal. So if type of self is not equal to the type of the other, then these are not the same types. So return false, because there's no way that, unless you want to, I guess we could check the type of it. And if the type of it was an integer, we could call the eval function and see, but that's, save that for another time. What kind of infinite loop do I have going on there? Oh, that. How do I check to see if myself is equal to the other? Apparently that's not how. I just wrote a recursive function, a recursive method, right? Because it goes in here and then it calls this call is actually calling underscore underscore equal, so it's recursive. So let's go see the correct way to do it because I didn't get it right. Oh, if self is other, that's our important keyword there. So not equal equal is. I think I'm going to get rid of that print message. All right, and so it's true that F1 is equal to F2. Else colon print no bugs. All right, so if you're going to create a function, it's a really good idea to add an init method. It's pretty much mandatory. It is a good idea to allow it to be converted to a string just to make it easy for debugging purposes, right? If you print out the object, you get a list of all of its pieces of data and boom, you're done. So let's do something else. Get off the idea of the fraction. Let's write a circle class. And all the circle is going to have is a radius. So it's got one piece of data. So the init function, the init method, needs to take one piece of data, which is the radius. And so we set our self's radius equal to that parameter that is passed in. Now this is just a common trope of how to write these constructors, is to give this parameter name the same as a variable name. But we could have just done that, right? Where R is the radius. But you'll see this used over and over and over and over in many programming languages, where the value that you're setting inside the object and the parameter name of the function match. Why give them different names? All right, and what can you do with a circle? Well, what's the most fascinating thing in the world? How about the circumference of the circle? And then a get area of a circle. And the circumference is, 2 pi r, and the area is pi r squared. We're going to need remind me. Yeah, from math, import pi, something like that. Is it lowercase or uppercase, though? Math.py. All right. So why don't we go ahead and import math here so that we can use math.py when we call get circumference. So define get circumference of this object, of these. We're going to check our cells. We're going to check our radius and multiply it times 2 pi, and that's how we get it. So the circumference is equal to 2 times math.py times our cell's radius. See, that's why I like the this keyword instead, where I could say, you know, this object's radius, so this dot radius, but I'll stick with the Pythonic way of doing it. And that returns the radius, excuse me, the circumference. So how about getting the area of the circle? The area is pi r squared, right? So math.pi times r squared, self.radius to the power of 2, self.radius star star 2. Return A. How about if we just want the radius itself? Well, right now, we can get a hold of the radius just by calling dot radius, right? So if we do C1 is equal to circle 10. Then we could do print circle's radius is, end quote, comma, C1 dot radius. We might want to provide what are known as getters and setters, where you can set the radius and where you can get the radius with functions, with methods. I'm not going to bother because I don't mind just allowing myself to change the radius on the fly. All right, and so we did change the thing's radius right there. So let's add a string method so that we can check to see what we look like. So define underscore underscore str underscore underscore, get the string version of ourself. This is equal to circle radius of placeholder 0 end placeholder end quote dot format parentheses this dot radius in parentheses and then return S. That way we can print out what we are, right? Print C1. Or there, oh, I did it again. I am so sorry. It is so deeply ingrained to me to use the keyword this rather than self. All right, and so that used the version, the string function, the str function in order to convert it to a string to print out. All right, so if we know how to get the circumference and we know how to get the area, let's actually do those things, right? So C is equal to C1's dot get underscore circumference, circum. A is equal to C1 dot get area. And we can print those out, right? Oh, I got it. I got to use the new version. So print parentheses F quote circles circumference equals open curly brace C close curly brace area equals open curly brace A close curly brace end quote in parentheses. All right. Is that a bit excessive? Do we need that degree of precision? No, we don't. So we could use our formatting, our formatted print statements in order to make it only show 2 decimal places. So colon, how about 3 decimal places, dot 3f, and after this variable as well, colon, dot 3f. All right. Let's define another one. More examples, the better. How about a triangle class? It's going to have a height and a base, right? So define triangle. No, excuse me, class triangle. We are defining our triangle class. So we use the class keyword, and then its function needs to take a base and a height. So we're going to be setting ourselves with a base and a height. So self.base is equal to the base argument passed in. Self.height is equal to the height argument passed in. And what is the area of a triangle? It's just base times height divided by 2. So define get underscore area, parentheses, self in parentheses. Note that every function we call has this parameter here. And I'll make another comment about that just for a moment. But every one of these functions that is a method has a self parameter here. That self parameter is what makes it a method, that makes it able to access the data that is stored inside that object. And so the area of a triangle is just 1/2 of base times height, self.base times self.height. And return that area. Define the string version of it. String is triangle. Oh, heaven help me. The formatted string version of triangle base equals curly brace, this dot base, end curly brace, height equals curly brace, this dot height, end curly brace, end quote. Return the string. All right. I never actually used it, but at least it compiled. So let's create a triangle. T1 equals triangle with a base of 10 and a height of 20. Let's print the triangle out, and then let's get his area. A is equal to T1 dot get underscore area, and then print triangle's area is end quote comma A. I did it again. I wish I could make my keyboard give my fingers a little electrical jolt, or I could just give up using the self keyword and use it, call it this instead. Okay. All right. And so it worked. The triangle's base and height is 20 and his area is 100. All righty. So in each case, we have data such as a fraction having a top and a bottom, and we have functions methods that use that data. In this case, we could, we divide the top by the bottom to evaluate it. What other things might we want to do with a fraction? Things to add that would be cool would be a simplify, right? So if it says 2 over 4, we'd like it to become 1 over 2. That'd be nice. And then add and subtract and multiply and divide. Those would be nice to add to this. So methods we could add. For our circle class, I don't know what else we could add. For our triangle class, I don't really know. I don't think you can calculate the perimeter of a triangle just based purely on its base and height. I think you also have to know the relative location of those things. There's the positionality of them to get the perimeter of it. I'm going to leave that alone. How about one more, which is just a block with an X, Y, and a Z, or a height and a width and a depth. Define block. And by the way, it's common programming practice to name all of your classes with an uppercase letter. And that's just to distinguish them from anything else. And you notice that I followed that pretty carefully, so that anytime we're about to create an object, we make this call, it's got an uppercase letter. Why? Why bother doing that? Because it distinguishes it from a normal function call, right? If what you're doing here has an uppercase letter, we know that we're just not merely calling a function called circle, we are creating an object of type circle. We know we are creating an object of type triangle, not just some function called triangle. You don't have to do that, right? This would have worked just as well if I'd made all of my class names lowercase. So a block. Init. Define the init version. Init. And this thing's got a height and a width and a depth. So self.h is equal to h, self.w is equal to w, self.d is equal to d. And so the volume of a block is its height times its width times its depth. So we're going to do a get volume. Def get volume. Every method has to accept a self parameter. So the volume is equal to self.h times self.w times self.d, and return that volume. So we can create a block, right? B1 is equal to block of 10, 10, 10. B2 is equal to block 20, 20, 20. The volume 1 is equal to B1.getVolume. Volume 2 is equal to V2.getVolume. And we can print those out, right? Just going to copy and paste that to print out the volume of 2. And what did I do wrong here? What's the difference between the way I define that block class and this triangle class? Obviously, I used the wrong keyword. Don't know what I'm doing here. I'm pretending I have a block named V1 when it's actually B1 and B2. And so there we go, right? Those are our two volumes. No, when I copied and pasted it, I didn't change it to BV2. And 10 times 10 times 10 is 1,000. 20 times 20 times 20 is 8,000. So good enough. So, although they don't give us the source code for it right here, they're talking about a class called student, which apparently is stored in a file called student.py so that they can import it. I could have put my triangle in a class called triangle.py so that I could just do import triangle and so on. And then they create a student. And when you create the student, you're passing in a name followed by a number. And then if you print the student, it prints out their name followed by 5 numbers. Apparently this 5 here is the number of test scores. And then they are setting each score. The first test score was 100 and so on. So from that, we can kind of figure out what they're doing, but we have this explicit listing now of the interface, which is that you create a student, you pass in a name, which is the name of the student, and the number of scores. You can get the student's name if you want. Get score will return the student's test score for that particular score, where I must range from 1 through the number of scores. Apparently, we're not doing zero-based indexing here, right? We're not doing score 0 and score whatever. Or you can set that score, you can get their average, and you can get the high score, or you can convert the entire student into a string. Now, they must have the source code for that in the book, because it certainly isn't in the PowerPoint. Doc strings can appear at 3 levels. You can have a doc string at the module level, at just after the class header, or after each method's header. And then help prints the documentation for the class and all of its methods. So when we run this, and then if I did help fraction, not going to tell me anything. I don't have very much in there. What? Because I have not added any doc strings, right? The fraction class could have a doc string to explain what it is. Did they give an example of that? Because I don't really tend to document my functions and things. Okay, here's a doc string. The doc string is just our triple quote thing. Let's try adding some doc strings to one of our classes. Fraction class, since I was so intrigued with it. Block class. So a block occupies volume and has HWD, height, width, and depth attributes. And what does the init function do? Initialize the blocks HWD, height, width, depth. What does the volume do? Return the volume of the block. So now when we run it and we type help block, we're going to get a little bit more useful information out of it. So what is a block? A block occupies volume and has HWD, height, width, and depth. And I don't know what I mean by occupies volume, right? But it's just a geometric shape that's got a height, width, and a depth. It's got some methods. It's got a method called init that initializes the block's HWD attributes and returns the volume of the block. So the init method is called the constructor. It runs automatically when the user instantiates the class. So the init method for our student class accepts a name and then a number that represents the length of the class, of the list of scores. They're using a for loop here to append the number of scores to the list. You don't got to do it that way. If you have if you want to make a list that has 1,000 blank elements in it, it's just as easy as doing this. Right there. Now we have a list that's 1,000 elements long. So they didn't have to do it the way they did it there. But it works, right? You use a for loop and append 0 to that empty list 1,000 times. That does work. Classes usually include an str method that returns a string representation of the object's state. When the string function is called with the object, str is automatically invoked to do the conversion. Why do you want to do that? Pretty much just for debugging purposes, right? You want to print out the value, the state of your objects while you're trying to figure out what's going on. So methods that allow a user to observe but not change the state of the object are called accessors. If we wanted to, we could add to our class some getters, which are known as accessors. We could do get H and get W and get D for block, or get base and get height and set base and set height. If it's getting something, it's an accessor. If it's setting something, it's mutating it. So it's called a mutator. If there's no need to modify an object, do not include a method to do that. So if I do not want to allow them to change the radius via function, I would not put a set radius method inside it. Now, it's good common programming practice to do something that's known as encapsulation, which is to hide the data of the object in such a way that it cannot be accessed directly. I could not call t1.base in order to change the base of it. I would have to call set base. And in order to do that, I would need to change the name of the variable to something a little bit less obvious than base. I'm going to kind of skip the idea of getters and setters for this lecture. I don't think that I necessarily need to do that. Before writing a line of code, thinking about the behavior and the attributes of the objects of the new class. Choose a good class name and develop a short list of the methods available to users. So the data is nouns, right? Every person has a first name and a last name and an address and a birth date, right? All four of those pieces of data are nouns, right? First name, last name, birth date. And then there are verbs that are associated with it. A circle has a radius, and you can get its area and get its circumference. So get area is a verb, get circumference is a verb. So you choose the appropriate data structures for the attributes, like radius for a circle, or height, width, and depth for the block. You fill the class template in with init and str. You complete and test remaining methods incrementally, and then document your code with doc strings, which I should have been making us do from day one. Every function we define should have its own doc string. As you've seen, objects and classes are useful for modeling objects in the real world. In this section, we explore other examples. We may be getting close to the end of our lecture. A rational number consists of two integer parts, a numerator and a denominator. Well, what do you know? That's my fraction class. Python has no built-in type for rational numbers, so we will build a new class called rational. 1/2 is equal to rational 1 comma 2. 1/6 is equal to rational 1 comma 6. Print that fraction. Okay, so 1/2 is 1/2. Print that fraction. 1/2 plus 1/6. That's interesting. This is pretty cool. It's doing some math on it to return the values of those two fractions added together. Are they equal to each other? False. Is 1/2 greater than 1/6? True. So they've added some operators to it. They've added the ability to add two fractions together, to subtract them, to multiply and to divide, kind of what I was talking about, and I forgot about modulus. And so if you're going to add support for the plus operator, you would need a __ add __ method. Adding, subtracting, multiplication, division. I wasn't going to fluff our fraction class out with this useful stuff, and so I don't think I'm going to stare too long at these formulas. But you know how to multiply a fraction if you remember your math, right? It's the denominators multiplied by each other divided by the, right, anyways. So here's a definition of an add method. If we wanted to add, no pun intended, support for the plus sign, we would need to tack this on. All righty, so here we go. I know I'm boring you. We're about done. We're about done. I don't think that we need to add a ADD, SUB, and etc. methods to our own fraction class, but we could, and maybe next lecture we'll go on and do that. We do need to talk about classes for another day, I'm absolutely sure. Then next week I'd like to talk about visual, graphical user interfaces if we've learned enough about classes by then. All right, so homework for this. Write a sphere class. The data that the class supports is a radius variable, and the methods are get area and get volume. You can just Google those formulas up. If you can't find the formula of an area of a sphere or the volume of a sphere, you can ask me, but you could always just do, area of sphere. Google that up and it'll show you the formula. Right. So I want to add get area methods to it. So it's definitely going to need an init method. I would like for you to add a string method as well. And it'd be kind of cool, I guess, if I made you add an EQ method to it to check to see if the objects were the same. I'm going to call that one optional. I'd like for you to do it just to prove that you can. And then so your code should create two spheres. Print out their area and volume. And if you added an EQ method, check to see if they are equal. That's one thing we could do. And then the part 2 of this is take our block class from the lecture and add a get area method. What is the area for a block? Surface area of a block is 2 times height times width plus 2 times width times depth plus 2 times height times depth. Please add docstring comments. All methods and file you submit. I think that's enough. I think that's enough homework. So we'll dip back into this chapter on Thursday. Are there any questions? I wonder how many of us are still here. Ooh, awesome.
So really the difference between, like, say, a class and a function is that a class is just a collection of functions?
Right. A class is a collection of data variables and functions. Correct.
Okay. Yeah, my phone keeps going off.
No problem. So, right. So our fraction class, we added too many functions to it to support, all the comparisons and stuff like that. But our circle, a circle has a circumference and the methods that, a circle has a radius. So the data that the circle needs to support is radius, and the methods that it needs to support, the functions it needs, are get area and get circumference. So the class is data, and then the functions that use that data, that manipulate that data. Are there any more questions? All righty. Well, I'm going to create the Dropbox then. And if we want to hang out and talk after we do that, then we can do that. So I'm going to go ahead and stop the recording now.